Alright, so in this video we are going to be using manipulatives to do integer operations, specifically subtraction. The TEK that goes along with this is a 7th grade TEK number 2C that's listed right here. You can see that 2C says use models such as concrete objects, pictorial models, and number lines to add, subtract, multiply, and divide integers and connect the actions to algorithms. So we're going to be using concrete objects, these red and yellow little counters, and we're going to be subtracting integers. In order to do this, we are going to have to use zero pairs. So I'll just go ahead and introduce what a zero pair is right now. A zero pair is when you have one positive and one negative. So a positive one and a negative one, when you add them up, it equals 0, so they cancel out. So we're going to be using these zero pairs. When we add them in, it's not going to affect the outcome of the problem, but it's going to allow us to subtract integers with the problems that we're going to encounter.
Okay, this is a problem that the students would see in their STAR test. It says the early morning temperature reading was 9 degrees Celsius. By noon, the temperature had dropped 15 degrees. What was the temperature at noon? So in order for students to solve this, we would have to start off with 9 degrees Celsius, and then we see that at noon the temperature drops 15. So we know dropping means subtract, and we'd have to subtract 15. Now we see that the students could run into a problem because we don't have 15 we don't have 15 to take away. So we would have to go below 0. So in order for us to get the students to do that, we are going to use counters and a positive and negative map to teach our students how to subtract integers using zero
Alright,
pairs.
so we're going to teach how to use the manipulative to solve problems like this using simpler problems, and then we'll come back and solve this question at the end after we've learned how to use our manipulative. So first I want to start off with a problem that is simple to just learn how to use the manipulative and what the yellow and red represent. So let's start off with the problem 6 minus 3. Obviously this is a problem that students in 7th grade would be able to answer very easily. But how we would do this is we would put 6, the first number in our subtraction problem, 6 yellow counters in the positive section of our map to show that we have 6 to start out with. Then we would take 3 away. So that would be taking away 3 positive integers. And we can see that what's left over is 3, and it's in the positive region. So the final answer is positive 3.
So now we're going to do a little bit more complicated problem. We are going to do 4 minus 7. And we see here that 4 is not bigger than 7, so we won't have enough on the positives to take away. So let's use our counters. We have 4 positive counters, and then, but we need 7 in order to take away from the positive side. So now is when we're going to use zero pairs. Now to use a zero pair, we add 1 positive and 1 negative. Because since we have a positive and a negative, they're going to equal 0, and since we're just adding 0 to the problem, it won't affect the problem. So we added 1 zero pair, and now we're left with 5 up here, but we still need 7 to take away. So we are going to add another and then 1 more. So now we have 7 positives and 3 negatives, and we can take 7 away. So now we're taking 7 positive counters away, and we are left with negative 3.
Alright, we're going to go through one more example of using this positive negative mat and the counters to solve a simple problem, and then we'll move on to word problems. So let's solve the problem 3 minus 9. To get this set up, we're going to put our 3 integers, positive integers in this section, we need to take 9 away. However, we can quickly see that there's not 9 to take away right here, so we need to make 9 be in the positive section of our mat. So we're going to add 0 pairs, and as we mentioned before, this does not affect the problem because it's adding 0. They balance each other out, so we have enough, just so that we have enough in our positive section to take 9 away. So there's 1, there's 2, there's 3. Let's see how many we have so far. 1, 2, 3, 4, 5, 6. All right, we need to add 3 more 0 pairs in order to have 9 in our positive section. So there's 1 more, and then finally 1 more. So let's count to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we have 9 positive counters that we're able to take away. We had 3 to begin with. We added the leftover 0 pairs to add up to 9 positives. So now that we can take those 9 away and see that we have 1, 2, 3, 4, 5, 6. 6 negatives left. So that's going to equal -6.
Okay, now we are going to start doing example problems using word problems. Now when we have a word problem, we need to find the information from the word problem in order to create our own problem. So this problem says a diver in the Olympics dives off a platform 10 meters above the water's surface and descends 14 meters. How many meters below the surface of the water is the diver? So if we're reading this, we know that he dives off a platform that is 10 meters above. So above would be a positive sign. So we know that it is a positive integer of 10 that we are starting out with. The water surface and descends 14 meters. So if we're descending 14 meters, that means that we're dropping 14 meters. If you see descend, drop, words like that, that means that we are going to subtract 14. So we see that we don't have 14 positive integers to take away, so we're going to use our counters and we are going to solve this problem using the yellow and red counters. So we know we start off with 10 positive integers. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 positive integers. But we need 14 in order to take away, we need 14 to take away from for this problem. So we are going to have to add 0 pairs. So here's 1, 2 0 pairs. Let's make some more room. 3 and 4. Now how many positive integers do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And we need to take away 14 positive integers. So we have enough, so we can take these away. And we are left with 1, 2, 3, 4. Negative 4 integers. So 10 minus 14 would equal negative 4 meters.
All right, so now we're going to move up a little bit more difficult word problem. We'll read it together. Anne's class is recording changes in temperature for science class. Students check the temperature readings each hour and determine the change in temperature. The chart shows the changes. What were the readings? So you can see we have this chart that we're going to need to fill out the temperature at each hour according to what the change is. So right at 8 a.m. it starts at positive 6 degrees. So we're going to have positive 6 in our little mat here. 1, 2, 3, 4, 5, 6. All right, and the change from 8 a.m. to 9 a.m. says dropped 5 degrees. And dropped, we see here again, as we mentioned before, is one of those words that tell us minus 5 degrees. So we have 1, 2, 3, 4, 5, 6, and we are able to take away 5 from those 6, so we don't have to even add any zero pairs. So 1, 2, 3, 4, 5. So after it drops 5 degrees, we're left with positive 1 degree Celsius. Then from 9 a.m. to 10 a.m., it drops another 3 degrees. However, now we run into the problem where we don't have 3 positives to take away. So we need to make there be 3 in the positive section by adding 0 pairs. So we're going to add 1 0 pair and another 0 pair. And now we have 1, 2, 3. We can see we're dropping 3 degrees, which is minus 3 degrees. So now we can take these 3 away, and what's left over is 1, 2 negatives. So negative 2 degrees at 10 a.m. Now, here's another issue that we're going to face. It's dropping another 1 degree. We don't have any to start out with right here, but the process is exactly the same. We need to have 1 degree to take away from at this time. So we add a 0 pair, and now we have 1 degree to take away from at 11 a.m., negative 1. So we can take this away, and now we're down to negative 3 degrees Celsius. And lastly, the final drop from 11 to noon is dropped 2 degrees. As you can see, we don't have any up here, so we need to get 2 positive counters up here to take away. So we're going to add 2 0 pairs. So now, it was negative 3, we had our negative 3 right here. We need to take 2 away. So we needed to add 2 0 pairs so that we could take these away. And now we can see that we're left with negative 5 degrees. So a question that could be from this problem is, what was the temperature at noon? And we would be able to say that after all the changes between each of these hours, the final temperature at noon was negative 5 degrees Celsius.
Okay, so now we're back to this question that the students might see on the STAR test. Now we read it earlier, but we're going to read it one more time so that it can be fresh in y'all's brains. So the question says the early morning temperature reading was 9 degrees Celsius. By noon, the temperature had dropped 15 degrees. What was the temperature at noon? So we know that the temperature started off at 9 degrees Celsius. So we write 9 degrees. And then by noon, the temperature dropped 15 degrees. And we mentioned before that when we see dropped, we know that we're going to be subtracting 15. So now we see that we have 9 positive integers and we have to take 15 away, but we don't have enough positives to take 15. So we need to use our manipulatives again in order to find this answer. So we're going to start off with 9 yellow counters. 3, 4, 5, 6, 7, 8, 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 counters. And we need to take away 15. So we'll add 1 0 pair, another 0 pair, another 0 pair. And now what do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is still less than 15. So we need to add a couple of more 0 pairs. 2. We'll add 1 more. 3. You see that that was a 0 pair. I know that they're not matching up. But now let's count how many positive energies we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we're subtracting 15 from the positive side, and we have 15 in this positive mat. So we can remove all of these, and we see that we're left with 1, 2, 3, 4, 5, 6 negative integers. So 9 degrees minus 15 degrees equals negative 6 degrees Celsius. And we can look over here and see that that answer is B.
All right, now we come back to our TEK, and we can see that 7th grade TEK 2C has been completed using models such as concrete objects, which is what we used with our positive, negative integer counters, to specifically subtract integers. So now that students know how to use this concrete manipulative to subtract integers, they would explore and get an understanding of how to do this and then eventually move to the algorithm. However, they could always easily use this manipulative by drawing it out on any exams that they may have when the manipulatives aren't available by simply drawing a positive negative mat and drawing their integers in, adding the zero pairs, taking away and see what's left over, to check to make the connection between the algorithm and the manipulative use.